Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to go through an introduction to the complex numbers. The complex numbers are a beautiful, fascinating branch of mathematics. They're usually studied at A level in the UK. So we start from the quadratic formula. So if ax squared plus bx plus c equals 0, then we know that x equals minus b plus or minus the square root of b squared minus 4ac over 2a. So let's just apply this. X squared minus 3x minus 4 equals 0. Substitute this into the quadratic formula. We get x equals 3 plus or minus the square root of 9 plus 16 over 2. 9 plus 16 is 25. Square root of 25 is 5. So we get x equals 3 plus or minus 5 over 2. If it's plus, then 3 plus 5 over 2 is 4. If it's minus, then 3 minus 5 is minus 2. Over 2 is minus 1. So x equals 4 or minus 1. That is easy. But what about this? X squared plus 6x plus 13 is 0. If we apply the quadratic formula, we get x equals minus 6 plus or minus the square root of 36 minus 52 over 2. 36 minus 52 is minus 16. Now, what is the square root of minus 16? Well, we need a number that we times by itself to give minus 16. So 4 times 4 is 16. And minus 4 times minus 4 is 16 because the minus signs cancel out. So there seems to be no number that we multiply by itself to give minus 16. And so therefore, we imagine a number I that is the square root of minus 1. So we imagine this number such that I times I is minus 1. So if that were the case, then 4i squared would be 4 squared times I squared, which would be 16 times minus 1, because minus 1 is I squared, which gives us minus 16. So there's two things we know about this number I. When we square it, we get minus 1, and then we're just going to treat it like any other number. And if we do this, it turns out we have a beautiful, workable number system, which actually gives us loads and loads of new insights. So going back to our example, x squared plus 6x plus 13 equals 0. We applied the quadratic formula and got to here. We got to minus 6 plus or minus square root of minus 16 over 2. So then we can just say, well, square root of minus 16 is 4i. So it's minus 6 plus or minus 4i over 2. So if it's the plus, it's minus 3 plus 2i. And then if we take the minus sign, it's minus 3 minus 2i. So those are our two solutions. And these are complex number solutions. So complex numbers are numbers that combine the real numbers and the imaginary numbers. I just think it's important to say that they're called complex numbers, but really that doesn't make them complex. I mean, like all of mathematics, they're really easy to understand once you're familiar with them. Complex numbers is just a name. I mean, it's a cute name, but it's important to not read too much into a lot of names in mathematics. They're just labels. So here, anyway, complex numbers are anything that's a combination of a real and imaginary number. Within the complex numbers, all quadratic equations have two solutions. So within normal numbers, within real numbers, the numbers that we've usually used, some quadratic equations have no solutions, like the one we just looked at, has no solutions within the real numbers. Within the complex numbers, all quadratic equations have two solutions. I mean, in some cases, the solution might be repeated, a repeated root. So it's just the same number repeated. This is even true if the quadratic equations have complex coefficients, actually. And actually, all polynomial equations of degree n have n solutions. Again, some of which might be equal or repeated roots. Okay, but can you just make up a number? I mean, we've just made up the imaginary numbers. Can you do that? Well, this is the way to think about it. We start with the counting numbers, right? So let's just say we're farmers and we're looking after sheep. We start with the counting numbers. I've got 9 sheep. Then one of them has babies. We've got 11 sheep. And then we learn to add. So you might say, well, 9 plus 2. 9 sheep plus 2 sheep, that's 11 sheep. So you're learning to add. You learn to multiply, which is to say there are 6 farmers in this village. We've all got 9 sheep each. Together, that's 6 times 9, that's 54 sheep. You then learn to subtract. So you can say, well, I had 6 sheep and I added 5 sheep to make 11, but then I took 5 away, back to 6. So subtraction is the inverse of addition. Division is the inverse of multiplication. So you could say, well, 6 times 5 is 30, and then 30 divided by 5, we're back to 6. So you create these operations as inverses, but all of a sudden then we need 0, because you can say, well, I had 6 sheep, I took 6 sheep away, so now I've got no sheep. So 6 minus 6 is 0. And you need negative numbers, because I had 6 sheep, and actually I owe somebody 8 sheep. That means I've kind of got minus 2 sheep. I kind of owe 2 sheep. So you have to create 0 and negative numbers to make subtraction work. Then you need fractions to make division work, because you could say, well, 54 divided by 6, that's just 9. That's relatively easy, but 15 divided by 6, okay, so that's going to be 2.5, because 6 doesn't exactly go into 15, and so we need fractions to make division work. So what we've done is we've created 0 and the negative numbers to make subtraction work. We've created fractions to make division work. We actually need some more numbers, which we call the irrational numbers, to make positive square roots work, because we can prove that the square root of 2 is actually not a fraction, or the square root of 3 is not a fraction. So we need new numbers to make positive square roots work, and then finally we invent the imaginary numbers and then the complex numbers to make negative square roots work. So actually the imaginary numbers or the complex numbers, they're just part of a journey that we've started a long time ago. So there's nothing particularly odd or weird about them. Anyway, I hope you've enjoyed this quick introduction to complex numbers. We'll do more soon. If you've enjoyed it, please hit like. If you want to see more, please hit subscribe and notification bell. We will send you more. I hope you enjoy your maths. Please send me any problems that you have, and I really look forward to seeing you next time.